Hi, this is Brandon Baines in the Department of Mathematics at Lipscomb University, here to talk to you today about the definition of a function. In this app, we're going to learn the definition of a function. We're going to learn various ways of representing functions, and we're also going to use those ways of representing functions to determine if we are looking at a function when we look at a set of ordered pairs. So the question, why should we study functions? The real reason is functions are one of the main tools used to communicate mathematics. Functions are used to express relationships between two or more quantities. And for that reason, much of higher mathematics, as well as applied mathematics, use function and really build upon that concept. The definition of a function states that a function is first a set of ordered pairs. Ordered pairs come in the form x, comma, y. And that's nothing really special. There are lots of sets of ordered pairs out there. You may collect data and gather sets of ordered pairs. You may have other equations that are also sets of ordered pairs. So that first part of the definition does not distinguish functions from other sets of ordered pairs. The second part of the definition does, though. They're sets of ordered pairs in which every x value is paired with exactly one y value. And so the real key here is that every x goes to or is paired with exactly one y value. The set of all x values is called the domain of the function. The set of all y values is called the range. Some people define function slightly different from what we've stated above. Some people define it as a rule that associates every input with exactly one output. So we still see the relationship of each x, which in this case the definition is calling an input, is paired with exactly one y value. In this case, we're calling it an output. The added language of a rule is really thinking about the fact that we oftentimes have equations that tell us how to find the y value for a given x. So this definition includes that language. The key aspects of the definition of a function is that it's a set of ordered pairs and that every x is paired with exactly one y value. We're going to talk about three common ways of representing functions in this app. The first of those is just to write the equation. Okay, that is, just state the relationship between the x value and the y value. So an example might be that if my wife makes twice as much money as I do, then we could write the equation y equals 2x, where y is representing the amount of money my wife makes and x represents the amount of money that I make. So in this case, if I made $60,000 in 1 year, we would know that my wife made twice that. She made $120,000 in that year. Should be noted that writing equations, that's not particularly special to functions. We can have equations that don't satisfy a function. So again, this is a tool to communicate not only functions, but other types of relationships as well. Second common way of representing functions, also common to representations of other sets of ordered pairs, is to simply write an XY table that represent the relationship between the x value and the y value. And here we have the same scenario of my wife makes twice as much money as I. And we see that if I make $20,000, then my wife would make $40,000. If I make $30,000, my wife would make $60,000, and so on. A really important point about XY tables, they are only showing a finite number of ordered pairs that satisfy the relationship. Technically, like with this scenario, we could come up with an infinite number of XY relationships, and so it would be impossible to write them all down. So when we make XY tables, we will always only show a finite number of ordered pairs. The third common way of representing functions is to just graph the ordered pairs, graph the equation. And so here we've graphed the equation y equals 2x, and we can see various ordered pairs represented here as we follow the line. We can see that when x is 1/100th, so I'm not making very much money here in this graph. I graphed this using Wolfram Alpha, and they picked the set of x values that they were going to show us here. But when I make 1/100th or 1 cent, my wife makes 2 cents. That still satisfies the relationship of every amount of money I make, my wife makes twice as much. So we want to use these representations to answer the question, is this a function? So let's see if we can determine whether we have functions in some different examples. Example 1 is the set of ordered pairs represented by the equation y equals 3x, a function. Let's take a look first just by plugging in an x value. And so I'm just choosing x to be 4 here, and we'll just see what we get for y. So when we let x be 4, we see that y is equal to 3 times 4 plus 1, just following the rule of 3 times the x value plus 1. And so that is 12 plus 1, or 13. So when x is 4, y is 13. That would form our ordered pair 4, 13. Here we see we got exactly one y value for the x value 4. That's exactly what the definition says. However, it says that it doesn't matter what x value you use. So this should apply for any x value. So we haven't shown that is the case yet, but we can inspect the equation 3x plus 1, and we can determine that no matter what x value you use, you should only get one y value from that equation. A second representation of the equation y equals 3x plus 1 is to look at the xy tables. When you look at the xy table, you should see that for any x value, like when x is 0, we do get just a single y value paired with it, exactly 1. When x is 1, we get exactly one y value, the y value 4. When x is 2, we get exactly one y value, the y value 7, and so on. So now it appears that yes, I believe we are going to have a function here. So all of the inputs that we tried, again, this is a finite number of inputs. The number of the inputs all resulted in exactly one output. A third way to answer this question is to look at the graph. So if we graph the function y, or the equation y equals 3x plus 1, and we're asking, is it a function? We see here that no matter what x value you choose, like here I'm choosing this x value, and I go to the graph, you only see one, we only see one ordered pair plotted there, right? There's not any extra graph. There's no other ordered pairs plotted for this given x value. And you can continue to follow the graph down, and you see that happens. You might try searching vertical line test. That is another way to use a graph to determine if it is a function or not. And this simply states that if any vertical line crosses the graph more than once, then you would not have a function. So since we can follow this from left to right, and all of the vertical lines that we might imagine would only cross the graph once, we can conclude that this is a function. Okay, so yes, it is indeed a function y equals 3x plus 1. Let's consider x equals y squared. Again, we'll do the same thing like we did before in the previous example. Let's look first at just what the equation does. So let's choose x equals 4. When we choose x equals 4, we would have the equation 4 equals y squared.